In this video, we will talk about the inverse tangent function. So we're gonna look at the tangent curve. Okay, clearly it's not 1-to-1, so we're just gonna take one whole period of it because it just kind of just makes sense, right? This is gonna continue oscillating, but it just makes sense for for one period to just be just one piece. Okay, so here this guy is going to be the tangent of theta. Okay. And here you can see that the domain is going to be where one period is located, which is negative pi over 2 to pi over 2, and these guys are not included. Okay, and the range in this case is going to be, well, all real numbers because it can be anything. So from negative infinity to positive infinity. Okay, so in this case, we're going to pick a point just like how we did here. You can see that this guy's going to be, what point is that? That's going to be negative pi over 4 and negative 1. The inverse of this is going to be negative 1, negative pi over 4. Okay, so if I put negative 1, negative pi over 4, that's going to correspond with this little point. So we're going to take all of these infinitely many points and plot them in here, and this is what we get. So basically now, my range, oops, not my range, my domain is going to be everywhere, all real numbers. Okay, everywhere, everywhere, everywhere. I can choose any x value that I want. Okay, left and right. And my range is only bounded between two values that are not included because you have these horizontal asymptotes from negative pi over 2 to pi over 2, which is this guy and this guy. Okay, so these are where my restrictions are going to be at. Okay, so now let's just jump right into two examples. So here I have find the following. So arctangent of negative square root of 3 over 3. Now notice here that the range, all of the possible values are going to be from negative pi over 2 to pi over 2. So if you think about it, you're only going to be in quadrant 1 and quadrant 4. And these guys are not included, so they're undefined at that point. Okay, so if you want to go ahead and just write, again, the angles, I think it'll be helpful. So square root of 2 over 2, square root of 2 over 2, and then 1/2 square root of 3 over 2, and then do it in the bottom. So this is going to be negative, oh no, that's wrong, positive square root of 3 over 2, negative 1/2, positive square root of 2 over 2, negative square root of 2 over 2, and then positive 1/2, negative square root of 3 over 2. Okay, so in this case, since we're looking for the arctangent of negative square root of 3 over 2, we got to think about how we're going to do that. Remember that to find the tangent of an angle is just going to be the sine over the cosine. Okay, so in this case, we require the sine, well, we require it to be negative, right? So that means that we're only going to be in quadrant 4, so this guy. And then we need it to be one of these particular angles. So where exactly is the sine over cosine going to give me negative square root of 3 over 3? So where exactly is that going to be at? Little algebra, you see that this guy is the angle that we're looking for, because if I divide negative 1/2 divided by square root of 3 over 2, you're going to get this square root of 3 over 3 negative. Okay, so this guy is on the bottom, which is going to be negative pi over 6. So that means that arctangent of negative square root of 3 over 3 is going to give me negative pi over 6. Okay, so that's my answer. So now let's do this last problem. So cosine of tangent inverse of 2. So just how we've had this in the past, we kind of already know we're going to make this equal to theta. So I'm going to say theta is going to be that. So we're going to look for cosine of theta. This is what we're going to try to figure out. Here, remember, theta is going to be equal to the tangent inverse of 2. Take tangent to both sides. So tan and tan, that's going to give me tangent of theta is going to be equal to, that cancels out, so I'm left with 2. So when I take my triangle, here is theta. This is the opposite over the adjacent, so this is going to be 2 over 1. Let's use the Pythagorean theorem. 1 squared plus 2 squared equals c squared. This is going to give me 5. So c equals square root of 5. Okay. Now all we got to do is find the cosine. And the cosine is going to be the adjacent over the hypotenuse, which is 1 over square root of 5. If you want to rationalize, you know that this is going to be square root of 5 over 5. Okay. Alrighty. And then we're just going to do, it's only one problem. Yes, we're only going to do one of these. Now, one of the things to just know is that they are inverse functions for cosecant, secant, and cotangent, but we're not going to cover them here. They're not really, I don't find them useful. So, or at least it's not really useful. Sorry if I offend anyone, but I think that's not something that we should really cover here. But just know that they exist. Okay, there's somewhere in there that you have the inverse cosecant and inverse secant and an inverse cotangent, but I'm just not going to cover them. So here, we're going to do an application problem using sine inverse. So suppose a 13-foot ladder is leaning against a building, reaching to the bottom of a second floor window, 12 feet above the ground. What angle in degrees does the ladder make with the building? Okay, so we have a building. Here's my building. Okay, and you have a window. Okay, and this particular, you have this ladder too. Ladder, and it's 13 feet. Okay, reaching to the bottom of a second floor window. Okay, and this guy right here is 12 feet above the ground. Okay, so what we want to figure out is what angle does this ladder make? Okay, so notice here that I have the other two lengths already. We're so used to having the angle of elevation, but now we don't have it. So we can think about what trig function would best fit this type of scenario. Well, clearly it's going to be the sine function, because sine of theta equals the opposite over the hypotenuse, which in this case is 12 over 13. Now think about what you're going to have to do here. Well, here, how am I going to find the value of theta? Well, how do I get rid of the sine? Well, the opposite of sine is going to be sine inverse. So here I'm going to apply sine inverse to both sides. Okay, that you can't see that, but sine inverse. That's going to go away, and theta is going to give me sine inverse of 12 over 13. Here is where you want to be able to use your calculator. So in your calculator, make sure that your mode is in degrees, because we want to find them in degrees. So press the button for sine twice to get sine inverse, and then you get 12 divided by 13. Okay, and what you should end up getting is, if I round this to 1 decimal point, it should be 67.4 degrees. This is going to be the angle that it makes. So just a really quick and nice way to kind of circle it all back, that sometimes if we don't know what this angle is, but we do know the other two measurements, we can easily figure it out using inverse the inverse sine, inverse cosine, or inverse tangent. So this is basically the application on finding the angle of elevation, and you can have it for angle of depression as well.